Hello, my little triglets. Welcome back. We're still working on conic sections. Today is section 11.2, and we're going to talk about ellipses. Ellipses are flattened out circles. So, the formula is a little bit the same, x squared plus y squared, but we have a squared and b squared underneath, and it's always set equal to 1. So instead of having a radius, we have two different denominators to represent the two different lengths of the axes, because an ellipse doesn't have the same radius. This might be longer than that, so that's where the difference comes in. If x is listed first with the a underneath it, you're going to have a sideways graph. If x is first with b underneath it, then you're going to have a tall graph. And A is always bigger than B. So whichever's the bigger one, of course, that makes that the longer side, so it'll make it either tall or make it wide. We call, if this is A and this is negative A for this distance A, we call from A to A the major axis because it's the big one. And from B to B, we call that the minor axis because obviously it's the smaller one. So if A was 3 and negative 3, that total distance would be 6, but A is 3, so A is half the length of the major axis. Okay, but you're going to know that that's A because over here where it's squared, you'll see it's a 9, so you'll know that it's A there. So let's see if we can take an ellipse and draw it just from the information that I give you. All right, so we have x squared over 36 plus y squared over 16 equals 1. So first of all, which one's bigger? Is the a, so a squared is 36, that means a is 6. B squared is the smaller one, that means b is 4. So drawing this, because a is under the x-axis, we go 6. 1, 2, 3, 4, 5, 6. 5, 6, in either direction there. And then we go 4 on the y-axis because it's under the y. And then we draw the ellipse. So it's that simple. Your major and minor axis points, you might have to do that. Your major axis points are just 6, 0 and negative 6, 0. For minor, it's 0, 4 and 0, negative 4. Now, in an ellipse, there are points that we call focus points. And they are points on the major axis that are used to actually draw the ellipse. And the rule is, no matter where you go, if you hit the ellipse from one of those focus points, it always ricochets down to the other one, no matter where you go. So if I did another one and I ricocheted up this way, it's going to hit over there. If I did another one and I ricocheted down here, it's going to come up and hit that one. That's how an ellipse is formed. The sum of x and y is always going to be the same for each of these ricochets. So it's like you have a piece of string that's moving all the way around. If I take it here and then I move it over a little bit, I have a new ricochet, and then I move it over a little bit more and I have a new ricochet. So it's just going to go all the way around the ellipse. We call those points focus points. Plural is pronounced foci. F-O-C-I, that's the plural of focus. Now the focus points are found by doing a little formula, and because it's making triangles and such, it looks almost like the Pythagorean identity, but it's not quite. Okay, so you're going to use this to find the foci. So let's plug in what we know. We know a squared is 36, b squared is 16, so that's 20. So c is equal to square root of 20. Take out the 4, you get 2 root 5. All I need to know are the points. You don't actually have to place them on the graph. Now, they're always on the major axis point. So since the major started with the x, I need to start with the x here too. So it's 2 root 5 and negative 2 root 5, 0. All right, let's do another type, still with ellipses. So I want you to find the major and minor endpoints and the foci, the focus points, given this 25x squared plus 9y squared equals 225. Now that's not exactly in the form we had before. Before we had an a and a b underneath, and we had a 1 out here at the end. So I'm going to force it to be a 1 by dividing by 225, and then I'll have to do it to everything to keep the peace in our algebra expression here, or equation. So 25 divided by 225 is going to be x squared over 9. 225 into 9 is y squared over 25, and this becomes 1. Now it looks a lot better. Our major axis this time is the y. So our major axis points are going to be 0, 5, and 0, negative 5. So minor then would be 3, 0, and negative 3, 0 because of that 9 over there. Focus points, 25 minus 9 is c squared. That's 16. So c equals 4. So your foci are the major axis points. So you're going to start with 0, 4, and then 0, negative 4. Okay, let's do one that doesn't come out so nice and neat. Let's say I have 3x squared plus 5y squared equals 20. Same thing, I'm going to divide by 20. So I have 3x squared over 20 plus y squared over 4 equals 1. Now something's a little bit oddball about this one. Normally we don't have a 3 up there with it. So if you're multiplying something by 3/20ths, that's the same as dividing it by 20/3. You just flip it over and put it on the bottom. So now we have what we need. 20 divided by 3 is almost 7, so this is the larger one. So 20/3, that's your a squared, and this is your b squared. So the process is the same after that. I just wanted to make sure you knew how to flip that over. Now, ellipses are not always in the center, not on 0, 0. So we have to add in a center, just like we did with the circle. It's x minus h squared plus y minus k squared. But remember, we have the a squared and b squared, and it's equal to 1. So this is not at 0, 0. The h and k now become our center. So let's try a problem with this idea. I'm going to go to the next page so I have a little more room. I want to find the equation of an ellipse that has the foci are 8, 3, and negative 4, 3. And we know that the major axis is 14 in length. Okay, so let's plot and see what we have here. So if I go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 3, I'm about here. If I go negative 4 and 3, I'm here. So these are the focus points. Those are the ones, the ellipse is going to be around these, okay? Oops. You know, I don't know exactly how wide it's going to be, but it's going to be something like that. The ellipse is going to go that far around. Whoops. Sorry, I hope that wasn't too loud. So we have to find the equation, which means I need to find a squared and b squared. So we could put that up here in order to, not plus, but and, in order to write the equation. We also need to find the center, because that's going to be our h and k. So the center is going to be here somewhere. If this is 8 that way and 4 that way, that's a total of 12. That must mean 6 must be the center point. So if I'm at 2, 3, that's 6 to the right and 6 to the left, and that would be the center. So I already know my center, and the best way to get it is from the drawing, or to find the center between those 2 points. So my center is 2, 3. Major axis is 14, so from negative A to A is a distance of 14. That must mean A is 7. Okay, so if A is 7. Now I don't know anything about B. I don't know how tall this thing is, but I do know between the focus points, if the focus points are between 8 and negative 4, that's a distance of 12. So if this is a distance of 12, then from here to here is C, that would have to be 6. So we know B, or A and C, we can find B from that using A squared minus B squared equals C squared. So 49 minus B squared equals 36. Negative B squared, I'm going to subtract and get negative 13. So B squared is 13. So B is the square root of 13. All right, now we can do our formula. So our major axis is the x, so I know that A goes onto the x, so A squared is 49. Oops, I forgot to put the center in here. So I need the center. Let's put B in there first. B squared is 13, so I'll put that here. And I got to put my center in. 2, 3 is the center, so negative 2 and negative 3. And then it's always equal to 1. So voila. There you go, if it's not on center. Okay, so tomorrow we're going to finish up. We need to talk about the general form, just like we did with the circle where you had to complete the square. So it's pretty similar. Won't take us very long to talk about it. Okay, so in the meantime, send a little love to Trig, and it will love you back. Ta-ta.